Hey guys, this is Mr. Bennett, and we are doing the review for the exam for Unit 16 in Conceptual Chemistry on acids and bases. So we're going to start with the matching section. Now, you can start with acids first or bases first. We can take it question by question. I really like to do bases first because I know that the B in bases tells me a couple things. So I'm going to find bases on this list. First of all, I've got bases taste. Remember, the B in base tells us that they taste bitter, so this is going to be L. We also know that bases are, and then if we look on the right hand side, we know that they are caustic as well. Caustic means that they break down organic materials. So bases are also D, caustic. Now let's go back to acids. So acids, in terms of their taste, we know that bases are bitter, right? So these guys taste sour. So this is going to be a J. And then remember that if bases are caustic, then acids are, and it's corrosive, which is all the way at the bottom, it's M. Okay, now the way I remember those and keep those straight is that acids, if you ever have, acids are in batteries, and if you ever have batteries go bad and they produce that crusty stuff around them, we call that corrosion. So the reason why that corrosion occurs is because acids are corrosive. Moving down the list, an acidic solution. Remember that acids, such as hydrochloric acid, are hydrogen donators. So when we look at the formula of an acid, it typically has an H in it at the very front. And so that H is going to be given off. So now if we look at it, let's find it, it's A. Yeah, right? It's right up here. Acids are going to be donators. So we can say A. Then moving along, a basic solution is going to be the opposite. So acid solutions, right, have donating protons. And then so then a basic solution is going to be a hydrogen ion acceptor, or also known as a proton acceptor. So that's going to be H. Moving down the list, molarity measures. We did this yesterday or today actually in our review. Remember, molarity measures concentration, which is C. Neutral solution is going to be a pH of 7. The way you figure out that it's a neutral solution is if the hydroxide is equal to the hydrogen ion concentration, and so that's going to be E. pH of 5, I taught you this trick that if the hydrogen concentration starts with a 1, like B up here, and the exponent then will give you the pH value. So 1 times 10 to the negative fifth is the same thing as pH of 5, so B is going to go here. pH of 11 is going to be the 1 times 10 to the negative 11, so that's going to be G. And then the last thing is, please make sure you know these guys. Strong acid, strong means it has a high rate of dissociation, which means to split, and so that's going to be K. And then a weak means that it has a low rate of dissociation, so this is going to be I. Alright, if you need help on the other questions, make sure that you watch those videos as well.